specific specific heat capacity 4200. 4200, it means that this C is 4200, the specific heat. That means C, if I, this is, if per 1 kg 1 degree centigrade I want to increase water, if I take 1 kg of water and 1 kg of concrete, and I want to raise the temperature by 1 degree, okay, that means I require 800 joules for concrete and I require 4200 joules for. That means it is very difficult. You need a lot of heat to raise the temperature of 1 kg of water by 1 degree. That means it's a very good, you require a lot of heat, okay? Because 4200 and this 800, so concrete will quickly get heated up, okay? Because so this will take time, water will take time because it requires a lot of more heat. So if you take 4200 and 800 and concrete and water values and you go to this situation, so I'll show you a situation in real life where near beaches what happens, near seas what happens. So we have got two things, there's a sun shining there, there is a sun shining there, and there are two things right in front of the sun. it will have it will have concrete, okay, something, land is something like concrete, and you have water, right? So sun is shining in the daytime. The sun is shining in the daytime. It's giving heat to both of them. Equal amount of heat is giving to both of them. The problem with concrete is it just requires 800 degree per degree rise, 1 degree rise, right? 800 joules or 900, whatever that value was. And here it is 4200 requires. So this guy concrete heats up very quickly compared to water, because water requires 5 times more heat for 1 degree rise. Okay. So this heats up quickly. So during the daytime in hot sunshine, the land heats up more quickly. But the sun takes time. The water takes time. Acha. So basically, this means that by the time this guy is, let's say, 44 degrees, this guy must be 24 degrees, right? Because he's taking more heat, and the water keeps coming from below and whatever. So the air above this is hotter. The air above the land will get, this land will start radiating, okay, and will start convecting heat to the air, and the air will come in contact and will rise because it's hotter now. And the air here is air at 24 degrees, this is heavier, okay. And the air, ha, no, yeah, density is lesser when it's hotter. Why? Obviously, because volume is more, it expands more. You see, density is mass over volume. So if it expands, the volume will increase, the density will fall, and so it rises. It rises. It rises, and then it starts going to the area where this air is generally. This is the heavier air. So this will rise to areas, and the heavier air will start taking its place because there will be a vacuum created here, because the air pressure drops, not vacuum as such, but the air pressure will drop because the air has risen up. So the heavier air will get attracted, and this is cooler air. So what happens is near the seas, the temperature doesn't really rise because in at night, in the day, warm air up rises above the land, it displaced by cooler air from the sea. So had there was no this 44 and 24 is coming, it makes it again 30 degrees, average it out, okay. So or you can assume it's near 25 degree or 30 degree somewhere, so it doesn't let it, the air over the water doesn't let it become too hot in daytime. Acha, in night opposite happens. Now this is again the specific heat is 900, uh, and again for 1 degree drop, it just requires 900 to be lost. You see, the right now it's the fall. So for 1 degree loss, you just require 900, and it will quickly radiate 900. So this will become colder. The temperature here, what was in the afternoon, supposing at night there is no sun and you're getting will now start radiating heat. Okay, both will start losing heat because then whenever the exterior becomes less in temperature, the body will absorb heat when it is at a lower temperature. It will emit heat when it is at a higher temperature. So when the sun goes away, the land and the water were hot because of the sun. The sun has gone. Now they will start emitting. Now this will emit, but it requires more 40 to 100 heat to be emitted for a 1 degree drop. This is 900 to be emitted for a 1 degree drop. And this will quickly drop and this will become cold. But this will be warm now because it's taking more time to cool down. And then the opposite happens. The cold air from this starts, the warm air from this rises and goes up. And the cold air. So basically you are getting now 24 degree or 24. So even if the drop it should have been very cold at night, 10 degree, it actually becomes 30 degree again, 25 degree again because 24 is coming from from this. So this is at night, the reverse happens. The sea stays warmer than the land, which cools down more quickly, and warmer air now rises above the sea as it is displaced by cooler air moving out from the land. So now you have to understand what is the difference between sea and deserts. Now in deserts, what happens is if you go to any Rajasthan area, desert area, you will find that it is very hot in the afternoons and very cold at night. Now this doesn't happen near the sea. It remains 30-degree continuously. And you don't feel cold at night. And otherwise, had this been a desert, if there's no sea, there's no water, then it becomes extremes. Otherwise, it remains temperate, cold, normal, both sides.